Good morning, one and all. I am Kranti Jes of Sri Venkateswar College of Engineering of Electronics and Communication Engineering. I am here to do a technical seminar presentation on optical camouflage design based on deep learning under the guidance of Shweta S. Kulkarni, Assistant Professor, Department of ECE, CG Bangalore. These are the contents: introduction, history of technology, methodology, results, applications, conclusion, references, etc. And this is the introduction. Camouflage is the most effective and common means to combat military recognition and total concealed military equipment. There are animals in nature with excellent camouflage habits. The principle of these animals is to use nervous system to sense changes in the environment and control the cells on the skin to change into different colors and textures. It is simulated by electric field to change colors. Along with this device that change colors to magnetic field also reported. Hence, optical camouflage design method based on deep learning was proposed. This method can be realize the recognition of camouflage target in near real time. Optical camouflage. It is a kind of active camouflage. It is completely embosses the viewer. It displays an image of the scene on the side opposite to viewer. The viewer can see through the weaker, making viewer invisible. History of technology. The idea of rendering objects invisible or camouflage dates back to ancient myths and legends. The development of metamaterials in the late 20th century laid the groundwork of practical applications of optical camouflage. In 2006, researchers at Duke University created a prototype invisibility cloak using metamaterials. This early vision was able to cloak small objects from microwaves. Advances in optics, nanotechnologies, and material science have contributed to the development of more sophisticated optical camouflage technologies. These are the history of technology. And this is a methodology. Camera captures the real scene behind the viewer. Computer which is connected to the camera processes the captured image, just as you see the real scene. Projector connected to the computer and will see as if the viewer is transparent. Half mirror reflects the light partly and lets the rest through the image from the projector is projected on the viewer. Preliminary camouflage texture design based on deep field V1. The essence of optical camouflage is to make it be impossible for human eyes or optical cameras to distinguish a target from its environment. Deep field V1 is a generated image in painting model based on contextual attention mechanism. The framework of deep field V1 is shown. It consists of two stages. The first stage is a simple dilated convolutional network trained with reconstruction laws to rough out the missing contents. The second stage is to train the contextual attention layer. And this is a standardization of camouflage texture results. Standardization of camouflage texture based on k-means. Although the previous design was well visually integrated into the background, it cannot be directly applied to the actual camouflage due to its large amount of colors. Due to many colors, it will be difficult to operate practical projects. The patterns generated by the previous method changes with environment, which leads to huge increase in the color further. Hence, it is necessary to choose limited number of colors according to certain standards, replacing single colors. ಏನು ಹೋಗ್ಬಿಡ್ತು ಆಗ್ತಿಲ್ಲ ಇರು ಏನೋ ಸ್ಟ್ರಕ್ ಆಗಿದೆ ಇರಿಟೇನು Okay, preliminary camouflage texture. Initially, the target region detected by YOLO V3 was masked. The masked image was input to pre-trained deep field V1 model. As the deep field V1 model was trained with place 2 dataset, which contained different types of environment scenes. The complete image was obtained, which is called preliminary camouflage texture. The generated camouflage pattern had a texture consisting of to the environment. When the input image resolution was 416 into 416, the preliminary camouflage texture was generated in less than 0.2 seconds. Standardization of camouflage structure. In this figure shown, first the column shows the original image, second the column shows camouflaged image and it is not replaced by standard colors. Third color shows the camouflage with the standard colors. Comparing the figures, it is found that the camouflage performance decreased after filling the camouflage with standard colors. The method took 0.1 seconds with the input image resolution was 416 into 416 resolution. Applications. Optical camouflage technology can be utilized for stealth purposes, allowing military vehicles, aircraft, and even soldiers to blend into their surroundings and evade detection by enemies. Optical camouflage can be employed in surveillance and security systems to conceal cameras, sensors, or even entire structures from. In the automotive industries, optical camouflage could be used to make vehicles less visible to radar systems, enhancing safety and security features. Optical camouflage technology could find applications in consumer electronics such as smartphones, tablets, and wearables. Architecture and designers could utilize optical camouflage to build and structure the blend harmoniously with their surroundings, minimizing visual effect on the effective. This is the conclusion. Optical camouflage texture has important theoretical and practical significance. It is told that the method is effective in natural environment like forest, desert, grassland, and so on. But in artificial environments such as urban environment, the effect of the proposed design is not ideal. Further, we can improve the same method to efficient results for artificial environment. Finally, this proposed implementation has important potential applications values in future real-time optical camouflage. And these are the